Today we're going to be learning a new fractional age assumption, but first I want to go over the uniform distribution of deaths, the fractional age assumption of uniform distribution of deaths. And there were two different formulations for the uniform distribution of deaths. So from the first formulation, we got this first equation. Now, S is a number between 0 and 1, so it's a fraction. So SQX, where X is an integer. From the first formulation, we just multiply S times Q of X. From the second formulation, we get the lives at X plus S equal the lives at X minus S times the death at X. When S is between 0 and 1, not including 1, and X is an integer. And we calculated a few probabilities. Given P of 40 was this probability, they wanted us to calculate 0.4Q 40.2. And we got under UDD that would equal 0.0002108. Then, given Q of 70 and Q of 71, we calculated 0.7Q 70.6 under the uniform distribution of deaths as 0.007676. So what we're going to do today is we're going to learn a different fractional age assumption called the constant force of mortality. And we're going to learn its formulation, and we're going to take these two problems, calculate those same probabilities under the constant force of mortality, and we're going to see that the answers will look relatively the same. In other words, both formulations work wonderfully. So we're going to learn about the constant force of mortality. So this is our second fractional age assumption. There are more, but we'll just learn these two. And what we say is the force of mortality is constant between integer ages. So given that S is between 0 and 1, not including 1, X is an integer, and T plus S is less than 1, we find that S, P of X plus T equal P of X to the S power. So now, using this new formulation, we're going to do these two problems. So we're going to calculate P of 40. I'm given P of 40 as 0.99473. Calculate 0.4Q of 40.2. Well, the first thing we do is we take our problem, and since this is given in P's, we can change the Q to a P. So 0.4Q 40.2, the complement would be 1 minus 0.4P 40.2. Well, if this is S, and we have X, which is 40 plus 0.2, so this is my X, and this is my T, well, 0.4 plus 0.2 is less than 1. We have our integer of 40. S is a number, again, between 0 and 1, not including 1. We can use this formula. So this would equal, and we take P of 40 to the S power. And when we put that in our calculator, we get 0.0002108. That matches what we did under, what we got under the uniform distribution of deaths assumption. So both of those are identical. We got the identical answer. Not always, but in this case, surely we did. Now we're going to look at, given Q of 70 and Q of 71, find this probability. So we're going to start with our problem. Given Q of 70 equals 0.01043 and Q of 71 0.011670. We want to calculate 0.7 Q of 70.6 under the constant force of mortality, where this is what we get. This is the assumption of the constant force of mortality. If these are true, then I can find that probability. Now again, it's P, so we know that we're going to have to change that to P. So I'm going to start with just looking at this as a P. So I'm just going to start with this. Now I'm going to rewrite this, and if you remember, back in the day, remember that we had T plus U, P of X equaled T P of X, U P of X plus T. So I'm going to try to break this up in a clever way so that I can use my constant force of mortality. So I'm going to break this up as to 0.3 plus 0.4. That would give me the 0.7. P of 70.6. So I'm going to use this as my x. I'm going to use this as my u. And this as my t. So I'm going to use this formula. So this would be rewritten as 0.4 P of 70.6 times 0.3 P of 71. Now this is in a form that I could use very nicely, but this one not so much. So I've got to look at this one and work with this one. So I'm going to take this over here and work with this. Over here, if I let this be, let's do it, u of x plus t, I can solve this equation up here, t plus u, p of x, over t, p of x. Taking this, and what we're doing is we're trying to figure out a way to make a rewrite this. So first I'm going to start out taking this and solve for u, p, x plus t. So if I make my u in here 0.4 and I make my x 70 and I make my t 0.6, I can solve in here. I can then say p of 0.4, 0.4, 70.6 would equal, well, t plus u is 1. P of x, which is 70, divided by t, which is 0.6, p of x being 70. So 0.4 p of 70.6 just equals p of 70, 0.6 p of 70. But we know by the constant force of mortality, I can rewrite this. This would be p of 70 to the 0.6 power. And then, since these have a common base, this is like p 0.70 to the first, I can now subtract in here, so this is p of 70 to the 1 minus 0.6, which would be p of 70 to the 0.4 power. So I can rewrite 0.4 p of 70.6 like this. And we know how to rewrite this one. And now we can rewrite these in Q. 1 minus Q of 70 to the 0.4 power times 1 minus Q of 71 to the 0.3 power. And we can get our answer in here, doing 1 minus 0.01043. You get 0.9958217. Taking 0.010413 subtracted from 1 to the 0.4 power gives me this. 1 minus 0.011673 to the 0.3 power gives me 99648. I think it's a 96. Not sure. That could be 46. I'm not sure. I can't read my writing. And then when you multiply those together, you get 0.9923210087. I always say keep all this in your calculator. But that's still not what I wanted. I wanted this. So I know that 0.7 Q of 70.6 equal 1 minus 0.7 P, 70.6. So when I do 1 minus this number, I get 0.007679. When we look at what we got under the uniform distribution of deaths, we got 0.07676. So we got very close to this decimal place were we off. So you get very similar answers when using the force of mortality and the constant force of mortality and the uniform distribution of deaths. The last thing we talked about is sections 3.4, 3.5, and 3.6 in your books, talking about national life tables in section 3.4, and then survival models for life insurance for policyholders, and then 3.6 was life insurance underwriting. I ask that you read those sections because they're filled with very good information. And on our next class, we're going to be going over section 3.7, select and ultimate survival models. So thank you so much for watching, and I will see you next time.